Okay. In 6 unproductive practices in mathematics teaching, I listened to Julie Dixon share 7 different practices that are unproductive when teaching mathematics. For me, this seminar helped me realize that math lessons can be more harmful to students if they're not properly planned. So, the first unproductive practice is lesson objectives. Lesson objectives or learning targets can often be harmful. It's usually a requirement through schools, but it can give off the idea that each lesson is equal when they're really not. So, some lesson objectives sound familiar. So, if you're doing a lesson, she gave this example, if you're doing a lesson on long division versus making sense of a division, if students see that lesson objective, they're going to think that it's the same lesson. um, and it makes them lose engagement and not want to pay attention to the lesson. So to solve this, I can start in the activating strategy of the lesson. I can ask questions that prompt students on their thinking, and then I can encourage students to figure out the lesson objective on their own by asking questions with academic language and stuff like that. It's crucial that I determine the learning goal before I even begin teaching the lesson to avoid making lesson objectives sound similar. The next unproductive practice is using gradual release of responsibility. So this is the I do, we do, you do strategy, and it's not very beneficial for students when teaching conceptual math lessons. This strategy is bad because the teacher is doing all of the hard work. So they see the example, and then the students immediately copy the same thing instead of understanding what the concept is of the lesson. So using gradual release of responsibility can take away the productive struggle and make math lessons too easy for students. And there's no type of sense making used. So instead of this, I can use layers of facilitation. So this is where I would start with the whole class and I would use engaging task. And then I would work with small groups. So maybe they go back to their tables and work, and then work individually one-on-one to determine each student's progress and their understanding of the lesson. The next unproductive task is providing scaffolding. So scaffolding should be used just in case students need it. So I can wait to scaffold to encourage productive struggle. If you immediately provide the answer or question, you're taking away from the student's learning. It's okay to provide small hints, but keep it minimal and only offer hints that don't give the answer away. And then I can choose tasks that provide struggle and common errors to help students learn. This scaffolding should be used just in time and based on the struggles the students are facing. So you can't really like necessarily determine it completely before you teach the lesson. The next practice is introducing academic vocabulary. So it's important to provide concepts before procedures. I can start with letting the students create their own vocabulary using sense making and the vocabulary they already know, and then provide the mathematical vocabulary we use for certain concepts. So this helps keep students involved and encourages productivity. The use of academic vocabulary gives more access to students and helps teachers connect concepts to procedures. The next practice is neglecting opportunities to connect concepts and procedures. So the teacher's first goal should always be building conceptual learning. This helps not give the immediate answer or the goal of the lesson away. Conceptual understanding should focus on concepts first, then procedures. Conceptual understanding lets the students figure out how to solve the problem instead of giving them one direct way of solving, and it creates that productive struggle that students need. I can use conceptual thinking by connecting them with previous lessons we've learned. I can avoid teaching an algorithm or using only one procedure. All of this takes really strategic planning, and it can be done with a team of teachers to determine how the lesson should go and recognize when errors may be present. The next procedure is limiting students' thinking and small group instruction. So, small group instruction can be really beneficial, but it's important to look at what and how your small group instruction really is. Sometimes whole group instruction is more productive than small group instruction. Conceptual thinking should also be present in small group instruction, which is typically the issue is that it's not present there. Teachers should be able to explain reasoning with solutions. Students should be able to make sense of each other's mathematical work and provide constructive criticism. Um, this was her 7th reason that she said that she was just working on. and it's overlooking the needs of far behind students. So it's important to prioritize the RTI time and other interventions for the students who are behind. Instead of focusing on memorizing basic facts or reteaching everything that they don't know, you can focus on prerequisites. So you can determine what the most important content is for the grade and teach those instead of trying to teach everything. That way they can use these 3 or 4 different concepts with everything that they learn within that year. So, in conclusion, through the seminar, I learned seven different ways to create math lessons that focus on student learning. Realizing when these unproductive practices are present in my lessons can help me learn more from my students and overall create lessons that benefit my students more.